Today we're going to discuss about the fire alarm system. This training has been designed in accordance with NFPA 72 fire alarm and signaling code. So all these requirements is accordance with the NFPA requirements. So today we will look into the different types of requirement which is set by the NFPA for fire alarm systems. This training is a little bit lengthy, so I have prepared this training in 3 different parts. So today we will start with the part 1. Then after that I will upload the part 2 and part 3. Before we start our training, I would like to request you to please do not forget to subscribe my channel, like my videos, and please do share with your friends and colleagues as well. So let's start our training, fire alarm system. The concept of fire detection. First of all, we will look how fire will detect it. So this is the start, fire detection activation. So how the fire detection will activate. So start to produce POCs. Fire will come here, and after that a small ring, smoke will come up, produce visible smoke particles, and after then flame, produce a high temperature. It will create the high temperature. Then a sprinkler and hydrant will activate, and high heat will come up. And by the time it will, when the sprinkler and hydrant will activate it, the fire will go down. So this is the process of fire detection. Components of fire alarm systems. How many components are there in the fire alarm system? First of all, there is a detection. Fire or smoke will be detected, and that will be controlled, and that will be notified. Fire alarm control panels. Fire alarm control panel, we are calling it FSCP also. Fire alarm systems, auxiliary devices, smoke control systems, hood suppression systems, clean agent extinguisher systems, door release mechanisms, and elevator recall. All of these comes under the fire alarm systems. Smoke detectors, under the smoke detectors, there are heat detectors, manual pull stations, and then we have the water flow switches, then we have the valve temper switch, then we have the buzzers, bells, horns, and the stops. So these are there. There is the fire alarm control panel design, and there is the notification appliances are here. These notification appliances will give the notification to the fire alarm control panel. After then we have the secondary power batteries generator that will be activated, primary plus power source. Then we have the initiation devices. These devices will be initiate, and that will give the notification to the fire alarm control panel. And also off premise signaling to supervise the station. Controls for these systems are located in the FSCU, fire alarm control unit, and the FSCU can also perform other functions such as providing two-way firefighter communications. It will provide remote annunciator integration, then controlling elevators, HVAC, then fire doors, dampers, locks, or other fire protection features that will be connected by the fire alarm control unit. Fire alarm control unit. One of the most important parts of any fire alarm system is the fire alarm control unit, or as it is more frequently called, the fire alarm control panel, which we are calling, and which is often described as the brain of the system, fire alarm system. Over the past 40 or so years, fire alarm control panel technology has evolved from simple single zone relay type units that rings one or more bells to logic circuit type multiple zone units that provide additional system information and capabilities to sophisticated microprocessor based software driven panels that interface and control other building and fire safety systems. So when the fire alarm control unit was developed, from that time there are so many changes has been done, and there are so many good changes has been done in the design also, and the notification systems also, and certain other changes has been done since it's started. Earlier generation FSCP, fire alarm control panel. This is the earlier one, the first it was used. use conventional technology to link to manual fire alarm boxes, and bells to provide coded or non-coded alarm signals for evacuation. There is the bell that was provided. Use two wire circuits to establish initiating device and notification appliance zones. Then, depending on the arrangements of the wiring and devices, a and break in wire could reader any device beyond the break in operative. After then, there was some other changes. Later generation FSCP. Conventional technology panels featured modular equipment with the smaller electronic components and logic or relay circuits, 2 and 4 wire circuits to support initiating devices and notification appliances, and expanded performance and system monitoring capabilities for the later generation. 4 wire systems provide a higher level of reliability because the setup typically allowed for 2 wires to power the device and 2 to initiate the alarm. Whereas in the most other wiring configuration, a break in the wire or a device failure would disable other devices from operating. So this was some changes happen in the later generation of fire alarm control panel as compared to previous one. Is replacement possible with new generation panels? Is there any possibility that if you have the old generation panels that you can change with the new generation one? The good news is that yes, we can. When conventional panel requires replacing, in some instances, many of the new generation panels can be installed with the existing 2 and 4 wire systems and utilize interface models and software to communicate with the field device, so entire system do not have to be replaced. So you don't have to replace the all entire devices, only the FSCP that you can replace, or new generation panels can be installed with existing 2 and 4 wire systems that you can utilize also. Now that this is the latest generation fire alarm control panel, utilize state of the art electronics, microprocessors, and intelligent software that provide specific information concerning device identification, alarm location, and type. This is the new generation fire alarm control panel. It will tell you the location of the any defect and identification of the device also, and other specific information it will also show you on the display. It is commonly referred to as addressable technology, intelligent technology, or multiplex technology. Addressable intelligent technology is a very versatile, able to support all sizes of fire alarm systems, and extremely valuable to first responders, inspectors, building engineers, and service technicians because information concerning the specific initiating device, such as the exact location of the device, and in some instances, the associated problem is immediately available. If you know the location of the device and any area that you know and which device has the problem, you can take the action adequately and quickly. So that is one of the most important advantage with this type of fire alarm control panel, latest generation fire alarm control panels. Now, initiating devices. What are the initiating devices? And initiating devices interferes with the fire alarm control panel to provide manual or automatic means of activating fire alarm and supervisory signals. Manual activation requires a person to operate the initiating device. Automatic activation occurs when the products of combustion or an event associated with the fire automatically activates the initiating devices. There are a number of different operating principles for automatic activation, including thermal sensitivity, aspirating detection of products of combustion or radiant energy, movement of water, changes in air pressure, and signals from automatic extinguishing systems. So there are certain types of devices, initiating devices. Now let's see start the different types of initiating devices. First, we have the manual initiating devices. The manual fire alarm box is the only type of manual alarm initiating device. It is known by a number of different names, including manual box, manual pull box, and manual pull station. Whenever there is a fire, we will pull this red color down to activate the alarm. It is critical that these devices are accessible, unobstructed, visible, and constantly located so building occupants and visitors are able to recognize and use them. So whenever you are installing these devices, you have to make sure that these devices should be easily accessible. These devices should not be obstructed. They should be easily visible and consistently located in every building, every floor, each floor after the certain distance building. So the occupants and the visitors, they should know that how they have to activate that one and where it is located and what they have to do, and they can easily recognize them. So these are the certain requirements that you have to comply whenever you are installing any manual initiating devices. Manual initiating devices, the purpose is to provide a manual means of activating the fire alarm system at the first sign of a fire. Still, activation of a manual fire alarm box does not guarantee a fire department response, as the fire alarm system in many older buildings are not monitored by an on or off-site entity that would call the fire department. Therefore, in many buildings, there are cards, placards, or signs mounted above the manual fire alarm box providing instructions to notify the fire department after safely exiting the building. So whenever you are installing any manual initiating devices, above that one you have to put any sign, placard or any sign card that the person who is activating this manual devices, what they have to do, how they have to activate this one. So then manual initiating device installation requirements. What are the requirements for the installation? To provide for easy reach when exiting a building, as per the NFPA 72 requires manual fire alarm boxes to be located within 5 feet of an exit. That should be mounted between 42 to 48 inches above the floor, located on each side of exit opening greater than 40 feet wide, and located within every 200 feet travel distance measured horizontally on the same floor. So these are the requirements whenever you are installing any manual initiating devices. If the travel distance exceeds 200 feet, additional boxes are required. In addition, manual fire alarm boxes should be colored red unless the environment facilitates the use of the color. Manual initiating devices installation requirements. In locations where manual fire alarm boxes are subjected to moist, damp, or wet environmental conditions, they must be listed or approved for the conditions as well as appropriately protected to avoid problems with corrosion, rust, electrical shorting, and grounding. So, whenever you are and wherever you are installing these manual activation devices, initiating devices, you have to make sure that they are protected also from the certain hazards like moist, environmental hazards, and certain other things. So they should be protected to make sure that during the emergency they should be used appropriately. For these reasons, it is common to see some type of protective cover over these devices. So you can use these type of devices, and whenever they have to use it, they can lift it from here. Protective covers also help to deter individuals from pulling the box to create false and malicious alarms. Many of these covers incorporate a built-in mini horn or siren device powered by a battery. Once the cover is lifted, the mini horn or siren sound a local alert rather than tying into a fire alarm system. So whenever any person they will lift it, if there is no fire but they want to lift it, this one, so the security guard or the local people inside the building, they will be alerted also that someone has lifted this cover. Then how to operate MCP, manual control point. All manual fire alarm boxes operate on the same basic principles. You must pull a lever on the box to initiate an alarm. However, some boxes may have additional operational characteristics, and according to these characteristics may fall into one or more of the following categories. So manual control point. A manual control point, it could be coded, pre-signal, break glass, signal action, single action, double action, non-coded, general alarm, and non-break glass. There could be the different types of MCP. Non-coded MCP, manual control point. So when activated, this type of box simply initiates an alarm until it is reset. So it will initiate an alarm until the alarm is reset whenever you will activate this manual control point, non-coded. coded MCP, this type of box is assigned a code that sounds from an audible notification device. When a mechanical or electrical driven motor turns a wheel, a person can determine which box is operating by counting the code that is sounding. For example, if a box is assigned the code 415, then an audible notification device such as a bell will ring 4 times, pause, ring 1 time, pause, ring 5 times, and then pause again. So if it is 415, it will ring 4 times, then pause, then ring 1 time, then pause, then 5 times. So it is a coded MCP. Once the code is recognized, a person can look at the annunciator or compare the number of a code list to determine the location of the box. So once any person they will detect the code, then they can search for the location of the box. In addition, the system might record the event by punching the code onto a paper tape recorder, allowing responder or building personnel to verify the code or review the alarm information later. So this is the so that was for the coded MCP. Now we have the other types of MCP. So this is the pull down type. Then we have the two sound alarm pull down. We have to, if we have to ring the alarm, we have to pull it down. Then we have the other types pull down. This is the break glass. We have to break the glass if we have to use it. Now automatic initiating devices. Now let's talk about the heat detectors. We have the heat detector, which is a fixed temperature. These fixed temperature will work at fixed type of temperature. If any area temperature is 70 degrees Celsius and this heat detectors is set on 70, so whenever the temperature will reach 70, they will activate it. Then we have the rate of rise. Whenever the temperature will rise, they will activate a rate of compensation. This is the rate of compensation. We'll discuss about these things. Now we have the fixed temperature. A fixed temperature heat detector operates when a sensing element within the detector reaches a predetermined temperature. Some fixed temperature heat detectors use a fusible link sensing element that melts when the predetermined temperature is met, therefore requiring the detector or the detection element to be replaced after activation. So if you have, as I said, if you have set the temperature of any area or any location, 70 degree, 80 degree or 90 degree or 120 Fahrenheit, whatever temperature you have set, whenever that area temperature will reach that predetermined temperature, this heat detector will activate it. And once it is activated, after that you have to replace after activation also. So that is a fixed temperature heat detector. Then we are after that, other fixed temperature heat detectors use bimetal sensing elements, which include different bonded metals that expand at different rates. And when exposed to increasing temperatures, cause the contacts to close, sending a signal to the fire alarm panel. Once the temperature returns to a normal level, the bimetal sensing element returns to its normal shape and, if not damaged by fire, is ready for future services. So metal A, metal B. Now, metal A with the lower coefficient of thermal expansion, it has a low coefficient, and metal B with the higher coefficient of thermal expansion. So whenever they will come into contact with the heat, the special property of the bimetal where two types of metals are affixed together is being made used for here. The metal with the higher coefficient of the thermal expansion bands. So this is a higher coefficient, it will coefficient of thermal expansion, it will bend. So whenever they will come into contact with the heat, they will start to bend. And if they are not damaged, once the temperature returns to normal level, bimetal sensing elements returns to its normal shape. And if not damaged by fire, whenever the heat will come, they will bend. And whenever the heat will go, they will cool down and they will come on their normal shape. If they will not come on the normal shape, then they can't be used for the future use. If they will come on the normal shape, then they can be used for the future shape. They will come like this after the fire. If they are not damaged, they can be used. If they are still like this and if they are damaged, they can't be used for the future use. Line type heat detector. Line type heat detectors are frequently installed in challenging locations and environments because the detector in the form of a cable can be laid to confirm to the physical conditions. Some line type detectors are restorable, but others may need it to be replaced or at least have the part exposed to the fire replaced. After that, there are different kinds of line type heat detectors, but they all basically consist of sensing elements, example conductors in a special cable, surrounded by materials that change conditions when exposed to heat, causing the elements to make contact or become conductive. So this is the heat sensing polymer, sensitivity polymer, outer jacket, then protective type. It is a protective type that will protect here and still conductors. So if these cables also are not damaged, that can be used for the future use. If they are damaged, we can't use for the future. Line type heat detector, newer technology use fiber optic cables that sends a light source through the cable. When there are changes in the light source parameters due to the temperature change, the cable distorts, causing an alarm. So asset visualization, DTS, and there is the detector, laser pulses, and the back shafted light. Fiber is the disrupted sensors, glass, that is the laser. So when there are a change in the light source parameters due to the temperature change, if there is any changes in the light source, back shafted light, if there is any changes in the light here, then it will give the alarm, it will give the signal and the alarm will sound it. So line type heat detector will work on this. Now, rate of rise. A rate of rise detector is a heat detector that use pneumatic or electronic methods to monitor how much temperature change takes place over a fixed amount of time. When the temperature rise at a rate exceeding the fixed amount, either 5 Fahrenheit in 20 seconds or between 21 Fahrenheit and 15 Fahrenheit per minute, regardless of the starting the temperature, a signal transmitted to the fire alarm control panel. The pneumatic rate of rise detectors can be linear or spot rate detectors, both of which use rubber diaphragms to initiate an alarm. Changes in temperature are detected when heat expands the air in the tube that exert pressure on the diaphragm, line type, or when the air in the diaphragm is heated, spot type. So rate of rise heat detectors, they work if you have said that for certain time that much temperature should rise. But you have said that in 20 seconds the temperature should rise only 5 Fahrenheit, but within 20 seconds it's rising 12 Fahrenheit or 20 Fahrenheit. Then whenever the temperature will go above within certain time, then the temperature alarm will start to sound. Rate of rise, once the diaphragm is heated, it is enlarges to close electrical contacts connected to the fire alarm system. The electronic rate of rise detectors detect temperature changes through the use of a semiconductor component that responds to increased temperature by increasing electrical resistance. Rate of rise detectors typically detect temperatures change more rapidly than fixed temperature detectors and therefore may not be appropriate in locations where normal ambient conditions detect rates of temperature change that could cause false alarms. In addition, although rate of rise detectors are usually restorable after a fire, they may need some time to cool down before they can be reset. So there are some limitations with the rate of rise heat detector. So whenever you are installing any heat detectors as per the location wise, you have to consider these things before you are installing any heat detectors. Now we have the rate compensation. Rate compensation heat detectors. The rate compensation detector is a type of heat detector that responds to predetermined air temperatures and is not dependent on rates of temperature change. Rate compensation detectors are typically tubular and use a two-element sensing system. Then we have the to compensate for slow or fast temperature changes. The sensing elements are manufactured with metals that are designed to expand at different rates. During a slow rate of temperature rise, there is more time needed to heat the inner sensing element, thus giving the entire detector, including the outer sensing element, time to reach the rated temperature before an alarm is sounded. So rate compensation detector, heat detectors, they will work on the parameters of air temperature, not the varying temperature. So air temperature, predetermined air temperature. So whenever the air temperature will reach at that level, rate of compensation heat detectors will activate it. During a fast rate of temperature rise, it takes much less time for the outer sensing element to heat than it does the inner sensing element, resulting in an entire device activating an alarm at a lower temperature. This method of operation compensates for thermal lag conditions associated with the fixed temperature detectors. In addition, these type of detectors are restorable. So we can restore also these type of detectors. Now, automatic initiating devices. We have the smoke detectors, ionization, photoelectric. Under the photoelectric, we have the light scattering and obscuration. Then we have the air sampling, we have the dark type, and we have the video type smoke detectors. Ionization type smoke detectors, there is the metal plates and the metal plates up and down. Then we have the ionization chamber. This is the ionization chamber. Then we have the monitors current flowing in circuit. It will monitor the current flow in the circuits and the particle source. Photoelectric light obscuration, smoke particles. So there is the photoelectric. This beam detector provides the light source to the companion receiver on the other side of the protected area. The typical projection range can exceed 300 feet long by 60 feet wide. So this is the photoelectric one, transmitter for the optimum part, then individual indication and test diode, then the smoke particles, dispersed light, and receiver for optimum. Now, projected beam detectors, how it works. As per NFPA clause 17.7.3.7 projected beam detectors work on the following principles. Beam detector consists of sender and receiver. The sender and receiver be mounted firmly to avoid movement of the projected beam and possible unwanted alarms. The projected beam remain unobstructed by storage and ceiling mounted equipment or other objects that would result in a trouble condition on the fire alarm control panel unit and prohibit the detectors from sensing smoke. Smoke obscures the projected beam and reduces transmission of the infrared beam to the receiver. Beam detectors are for indoors use and are to be mounted to a stable surface. Mirrors can be used with projected beams per manufacturer's instructions and provided that mirrors are mounted to a stable surface. So that are the requirements. Now, projected beam detectors activation alarm signal. This is the transmitter. This is the beam obscuring matter. It is obscuring and receiver. And this is the receiver. So if it is obscuring and it will receive here. Projected beam detectors. As smoke obscure the beam, the receiver sensor decrease in the signal strength and measure that decrease. The receiver compress the signal level with two preset threshold. An alarm threshold that is set using the sensitivity switch and a trouble threshold that is preset at approximately 10%. If the signal falls below the alarm threshold for the programmed alarm period, the receiver signals an alarm. If it is below 10%, then that will start to alarm. Projected beam detectors. Projected beam detectors, as we know, this is the transmitter, this is the beam. These are the blocking object, and this is the receiver port. Now, where the light path of a projected beam type detector is abruptly interrupted or obscured, the unit should not initiate an alarm. So, if it is blocked by any other things which is not a fire or other thing, so alarm will not sound it. Here in this one, you can see that it is obstructed by the fire smoke, then it will start to alarm. But here it is not obstructed by the fire smoke. It is obstructed by the material. So alarm will not start. It should give a trouble signal after verification of blockage. If an object blocks the beam, the signal falls below the trouble should. If this condition lasts for 20 minutes, 20 seconds, the receiver signals a trouble condition. Then receiver will signal a trouble condition. Installation of beam type detectors, smooth sealing. So how you can install the beam type detectors. The effects of stratification shall be evaluated when locating the detectors. So before you are installing the beam detectors, you have to check for the certain things. So when you are installing this one beam detectors, beam is here and there is a fire. Whenever the fire will reach here at this level, this smoke will obstruct the beam and the fire alarm will start. Air sampling. So this is the air sampling type of detectors. Whenever the air sampling they will receive and the fire alarm control panel unit, they will start to start. Air sampling type smoke detectors. This is the air sampling type of smoke detectors. They are receiving from the certain areas and they are giving the sample to the fire alarm control panel. Air sampling type smoke detectors, maximum air sample transport time from the farthest sampling port to the detectors shall not exceed 120 seconds. So within 120 seconds, it should be give transport time from the farthest sampling port to system. Now detection chamber, there is the detection chamber, electronics here, aspirator, and there is the filters. So this is the display and laser chamber here, pure air, dual stage filters, filter sample air, aspirator, and inlet manifold. So this is the inlet manifold. The air will come here and aspirator, it will go here. And after then it will come here, filtered sample air that will come here. And after then the third stage, it will dual stage filter will come here and pure air it will come here. And there is the laser chamber. And after then it will activate it to the display. So this is the full cycle of air sampling type smoke detectors. Now this is the duct type of smoke detector, duct detector air sampling tubes. These are the tubes for the duct detector air sampling. Then we have the video, analyze the digital images and senses changes in pixels before there are enough smoke particles for visual detection, making detection many times faster than would be possible with a standard detector. So this video type of smoke detectors will visualize some images or the videos, and after that it will start the smoke detectors. Now, radiant energy fire detectors. There is the radiant energy fire detectors installed here. Gas sensing smoke detector. So this is the gas sensing smoke detectors. Now, signal processing alarm verification. How the signal will process and how the alarm will verify. In an effort to reduce false alarm, most modern fire alarm systems and smoke detectors have the capability to implement a protocol that validates the smoke conditions before a fire alarm signal sounds. So many areas, so many industries, there are fire alarms will initiate day to day, and the occupants they have to leave the building. Time will waste it, and the resources will waste it, and so many areas or so many like organizations, people they will use to these false alarm signal and they will not evacuate the building. So what will happen? They can't differentiate between the false alarm and the real alarm. But by this system, you can differentiate between the false alarm and real alarms. And if it is real alarm, then the signal will process and alarm will sound. So signal processing check the smoke within the detectors at specified intervals to ensure it continues to remain above a threshold amount. If the smoke remains above the threshold amount for the required time, alarm initiation takes place. So by this process, it will verify. After that, alarm verification. Fire alarm panel receive a signal from a smoke detectors and in turn either cuts the power to the detector or in the newer systems ignores the alarm signal for no longer than 1 minute to allow the condition to clear. If after this verification period the smoke condition remains, the detector sends a signal back to the panel to the alarm. So for 1 minute, it continues 1 minute. If it is within 1 minute, it is like completely stopped. Then it will not send the signal to the fire alarm control panel. If the condition will remain for more than 1 minute, then it will send a alarm signal to the control panel and alarm will start to sound. So this is the complete process for signal processing and alarm verification. Water flow initiating devices. So now we will look for the water flow initiating devices. Alarm pressure switch initiating devices. This is the alarm pressure switch initiating devices. Detector selection criteria. How you can select the detector. Which type of detector is suitable for your area. Whenever you are selecting any detector, you have to consider the design, type of area, type of activity, fire risk, and false alarm risk. So these are the things you have to consider whenever you are selecting any detector. So that's all for today part. So this is the first part I have completed. Next part we will start from the notification applications. Notification appliances. So I hope you like this video so far and the information which I have provided you now. And please do not forget to subscribe my channel and like my videos so you can get the notification on timely basis. And please subscribe my channel so you can get my second part of this video and the third part of this video so you can have the complete knowledge about the fire alarm system. Thank you so much. So see you in the next video.